basic building blocks: mercury, sulfur, and salt. His hypothesis led to centuries of vain attempts to transform one metal into another. And if anyone is tempted to mock these strange and outlandish experiments, this chemical groping in the dark would lead in a fairly direct line to the discovery of oxygen and the invention of modern chemistry. But it was the density of mercury that made mercury so useful in science.
I'm Hasek Chang, Professor of History and Philosophy of Science at the University of Cambridge. So what you do, you fill a glass cylinder with mercury, then you invert it into a pool of mercury. The column comes down to the height of, under normal weather, 76 centimeters or so, right? And above it, in the cylinder, is a vacuum.
What Hasek Chang is describing is the Torricellian barometer, an experiment first conducted in Italy in the spring of 1644 by two of Galileo's students, Viviani and Torricelli, who were trying to understand why conventional hand-cranked water pumps failed to work for wells deeper than 11 meters. By using mercury, almost 14 times denser than water, they could scale down the problem to laboratory size and made two crucial realizations. The first was that, as Torricelli wrote to a friend a few weeks later, "Viviamo nel fondo d'un pelago d'aria elementare." We live at the bottom of an ocean of air. Torricelli and Viviani had in essence built a set of scales that could weigh the many miles of invisible atmosphere above their heads against the weight of the mercury in the tube. Others would notice that the changes in height of the mercury presaged changes in the weather. It was clear that the barometer offered a glimpse into the future. It would provide the foundation of weather prediction and ultimately of atmospheric science. Barometers would make mercury the must-have accessory for every laboratory. It would become central to the study of gases, and with the development of mercury pumps, the availability of vacuum on demand led to the discovery of the structure of the atom, of the electron, and much more. What mercury had done was to open a series of windows into hidden worlds, revealing fields of science and technology that never existed before. But I had no inkling of this as I played with a bucket back in school in Nairobi. There were several things. First of all, the weirdness that your hands came out clean, that it didn't wet your hands. Uh-huh. Secondly, there was the fact that as you pushed your fingers in, you did feel squeezed, unquestionably. Yeah. It was, pressure became a very sensual, very physical thing. Mm-hmm. And then there was a final issue, and that was the fact that it was so cold. And as you pushed your hands in and it gripped you, it was the grip of death.
Wow.
And then you let go with your arm. And Archimedes' principle, the idea that your hands would float in the mercury, and they would just come up automatically, and then you'd push them back in and they would float again. It was amazing. Then our teacher walked in.
And what punishment did you get?
Well, after a certain amount of discussion and washing of hands, it was decided that we would hush it up. I'm not sure my parents ever found out about it. So if they're listening, now you know.
Until now.
Even after 18th century travelers found that it would freeze in the coldest places in Siberia, the mystery of why it is a liquid remained. It has only been in the last 20 years that theoretical chemists realized the secret of both its failure to tarnish and its fluidity, and that it comes down to something unexpected: relativity. The two outermost electrons of mercury move so fast that to describe them you must include Einstein's theory of relativity. As a result, these two electrons, the ones available for chemical bonding, are less available than one might expect, making mercury both liquid and so usefully unreactive. But the issue for me and for my teacher of having had direct contact with that mercury is its danger, something we've known for a long time. 2,000 years ago, Pliny spoke of it acting as a poison on everything, and yet it's been used in medicine.
Andrew Cunningham, former historian of medicine. So if you've got scabies or pubic lice, if you cover yourself with an ointment with mercury in it, they disappear.
To keep listening to this audiobook, I've left you a link in the description so you can do it, at no cost thanks to Audible's 30-day free trial.